Yes, welcome back to the session. In this video, I'm going to discuss about electric field due to uniform charged hollow sphere. Okay, so first of all, I'm going to draw the diagram. Let's say, for example, this is the hollow sphere of radius is capital R. So capital R is the radius of the hollow sphere. Now here we have a positive charge which is distributed over the surface of the hollow sphere. Okay, now around this positive charge I'm going to take Gaussian surface. As we know that Gaussian surface also imaginary spherical surface, right? So let's say, for example, this is the Gaussian surface. Okay, and its radius is smaller. Its radius is smaller. Okay, now I'm going to calculate electric field, right? So here we are going to discuss three cases. First, electric field outside the sphere. Okay, that means, let's say, for example, this is the electric field which is acting due to a positive charge. Okay, now what I'm going to take here, I'm going to take a surface area. Let us assume I'm going to take a small surface area, that is dA. Okay, in this surface area I'm going to calculate electric field, right? So according to Gauss law, I'm going to write here, according to Gauss law, we know that closed integral E dot ds, which is equal to q by epsilon naught, right? Correct or not? So here E, I'm going to take it out. Let's see, E into closed integral ds or dA, which is equal to q by epsilon naught. Basically, this closed integral dA, this is nothing but surface area of the Gaussian surface. Surface area of the Gaussian surface. Okay, so here surface area of the Gaussian surface means it looks like a spherical shape, right? So therefore we can write it as integral dA is nothing but 4 pi r square. Why I'm taking smaller? Because the radius of the Gaussian surface will be smaller. Okay, so I'm going to substitute that formula here, E into 4 pi r square, which is equal to q by epsilon naught. Okay, now this entire 4 pi r square, I'm going to take it into right side. It goes to the denominator. Let's see, E is equal to q by 4 pi epsilon naught into r square, or this expression we can write in another form. Let's see, so E is equal to 1 by 4 pi epsilon naught into q by r square. Okay, so this is the expression for electric field outside the hollow sphere. Okay, now coming to the second case. The second case is electric field at the sphere. Okay, so at the sphere means, first of all I'm going to draw the diagram. Let us assume this is hollow sphere of radius is capital R from the center. So here a positive charge is uniformly distributed over the surface of the sphere. Am I right? So according to the statement, we are going to calculate electric field at the sphere. At the sphere means I'm going to take a small surface area here. So at this surface area, the electric field is acting in this direction. Okay, so here instead of a small r in previous case, now at the sphere means the small r is replaced by capital R, right? The remaining expression will be same. So I'm going to write the condition here. If small r is equal to capital R, then electric field is equal to 1 by 4 pi epsilon naught into q by capital R square. Okay, so this is the expression when electric field at the surface of the sphere. Okay, now coming to the third case. The third case is very simple. Electric field inside the sphere or hollow sphere. Okay, let's see the diagram. First of all, I'm taking hollow sphere diagram here. Of radius is capital R. Okay, and a charge is uniformly distributed. So here positive charge is uniformly distributed over the surface. But according to the condition, we are going to calculate electric field inside the sphere, right? That means the Gaussian surface we are going to take inside. Let us assume this is the Gaussian surface. Its radius is smaller. So we are going to calculate electric field inside the sphere, right? So for this, I'm going to take surface area here. Let us assume that surface area is dA. Correct or not? But remember one thing, here the object is hollow sphere. So hollow sphere means inside the sphere charge is equal to 0 because the complete charge is uniformly distributed over the surface. Am I right? That means charge clearly 0. So whenever charge is 0, then automatically electric field also 0. So we can write it as electric field inside the hollow sphere also equal to 0. Okay, I hope you understand. This topic is most important 5-mark question, especially for PU board. Okay, sometimes in CBSE also they will ask. I hope you understand. Thank you very much.